Okay, dear students, in this lecture we are just giving you the PowerPoint presentation of set theory. In this session, we are going to study set, relation, and function. What is our objective here? We are going to introduce the sets, their representation, types of sets, subsets, and proper subsets, universal sets, and then the Euler-Venn diagram, algebra of sets, that is union, intersection, difference, complement of a set, laws of algebra of sets, De Morgan's law, then cardinal number of union, intersection, difference, and symmetric difference of sets. Set is any collection of distinct and distinguishable objects of our intuition or thought. I earlier defined it is a well-defined collection of objects. It is something like that. Well-defined means distinguishable and under our intuition. Following are some examples of sets: collection of vowels, the collection of all states in Indian Union, the collection of all past presidents of Indian Union, etc. Now these are some universal notations, so please go through it. These are standard notation that we are going to use. Now representation of a set, there are two ways. One is the roster method, or we call this as tabular form also. In this method, a set is described by listing elements separated by commas within the braces. For example, the set of even natural numbers can be described as, obviously we have listed inside the braces 2, 4, 6, 8. Then there is another method, that is the set builder method. In this method, a set is described by some characteristic property, and that property is nothing but we write px is something function of x, of its element x. In such a case, the set is described something like that, is a collection of all those x such that the property of px holds true. The symbol, this single vertical line or dash, is read as such that. In this representation, set of all even natural numbers can be written as collection of all those x such that x equals to 2n for n belongs to the natural number, or the alternative notation. Empty set. A set having no element is called empty set. It is also known as null set or void set. It is denoted by phi. For example, a collection of all those real numbers whose square is negative, which is impossible, so it is empty set. Another, that is set of immortal man, that is again empty. Singleton set, a set having only single entry is singleton set, namely singleton 2, singleton 0, singleton 5, or singleton set. As to the diagram, you can say it has only one member. Types of sets: finite set. A set is called a finite if it is called either void set, void means null set, or its element can be counted by a natural number and process of listing terminates at a certain natural numbers. For example, 1, 2, 4, 6 is a finite set because it has 4 elements. A set which is not a finite, that is counting up to whose element is impossible, is called an infinite set. For example, the set of all straight line in a given plane, the set of all natural numbers, the set of real numbers between 1 and 2, cardinal number or order of a finite set. It is also known as the number of elements in a set. The total number of elements in a finite set is called the cardinal number or order of a finite set. It is denoted by n of a. We used to call this is number of distinct elements. Set of set. Set of set is nothing but it is the set whose elements themselves are sets. For example, you can see this set. The members are set itself. So is but the set S, this is not a set of sets. S3 does is belongs to S is not a set. Okay. Now another example, equivalent or equal sets. Two finite set A and B are equivalent if their cardinal number is same. Cardinal number means the number of elements are same. Equal sets. Two sets are A and B are said to be equal if every element of A is a member of B and every element of B is again a member of A. Something like that. For example, A and B are equivalent and A and C are equal sets. Now these are some pictorial representation of equivalent and equal sets. Now see, these are some circumstances where the sets may be equal or equivalent. Subset. Set is said to be a subset of B if each element of A is an element of B. It means A is subset of B if X belongs to A imply X belongs to B. Now see the diagram. Set A has two members, so the subsets are, you can say that this single elements and the set itself, and you can say that empty circle is empty set. And now another counter example you can see on the screen. Proper subset. A set is said to be an proper subset of B if every element of B is an element of B and B has at least one element which is not an element of A. In other way around, you can say that proper subset is something, the set which is other than the set itself and empty set. So you can clearly see the example of proper subsets. Procedure for proving equality of sets. As we have discussed earlier, that sets A and B are said to be equal if every element of set is an element of and every element of B is an element of A. A is equal if both are contained in each other. Some results, every set is a subset of itself. The empty set is a subset of every set. The total number of subsets of a finite set containing an element is 2 raised to power n. Right now we are not in the mood to give the proof of it. When we do the binomial theorem, we'll discuss the proof. Power set. Set of all subsets of a given set. A is said to be a power set of A and is denoted by P of A. P of A is collection of all those S. S is a subset of A. That is, S belongs to P of A if and only if S is a subset of A. Phi belongs to P of A and A belongs to P of A for all sets, because empty set is a subset of all the sets. These are some counter examples you can see of power set. Now you can see the pictorial representation as well. Set having two elements, but power set has four elements. Universal set. What is universal set? You can see that a set which is superset, or you can say that it is the largest set under consideration. So it is denoted by either by ohm or U. Example, when we are using set containing natural numbers, then is universal set. This is the Venn diagram. So in the Venn diagram, the rectangle indicates the what we call universal set. Then these circles are nothing but the sets. It is a Venn diagram of A is a subset of B. Union of sets. You can see that A union B is nothing but collection of all those X. X is a member of A or X is a member of B. Clearly, you can say that if X is a member of A union B, if and only if X is a member of A or X is a member of B. But if X is not a member of union, then definitely it is not the member of none of the sets. So these are some pictorial representation. You can visualize it. Union is nothing but just simply merging two sets together. This is the generalized definition. Finite sets. If you have n sets, you can write their union this way. Intersection of sets. Intersection of sets is nothing but collection of all those X. X is a member of A and X is a member of B. Clearly, X belongs to A intersection B. Imply X is a member of A and X is a member of B. But if X is not a member of A intersection B, then X is neither a member of A nor a member of B. Now, these are some pictorial representation of intersection. You can easily see it in your screen. If nothing is common between two sets, these are disjoint sets. Difference of sets. A minus B means we are just considering the member of A but not the member of B. That is the exclusive member of A only. Similarly, you can define B minus A. Difference of sets, the different pictorial representation you can see on the screen, and you can make use of it, students. These are all the four possibilities we have made here. You can easily visualize the diagram. Algebra symmetric difference, that is we denoted by delta. It is nothing but the union of both the difference A minus B union B minus A. So clearly, when X belongs to the symmetric difference, it is not the member of A intersection B. So these are some pictorial representation of symmetric difference. You can see on your screen, and accordingly you can act. Algebra of sets under, that is complement. Complement is denoted by either A raised to C or A dash. A dash is nothing but U minus A, that is universal set minus A. So we can make use of the definition of difference of the sets here. X is a member of universal set but not a member of A. Now, so through the Venn diagram, you can easily visualize the outer part is nothing but, outer shaded part is the complement. Now, do you know this some fact? Complement of universal set is empty set. Complement of empty set is universal set, and the complement of complement is set itself. And A union A complement is universal set. A intersection is the empty set. Idempotent laws, that is A union A and A intersection is A. Identity law, A union phi is A intersection universal set is A. Phi and U are identity elements for union and intersection respectively. Commutative laws, A union B is B union A intersection B is B intersection A. If you want to do the proof, you can see on the screen. So we have just used the equality of the sets. Two sets are equal if they are contained in each other. You can easily do the proof of it. So right now the proof is not required, but if you want to see on the screen, you can easily see that how we are exactly doing it. Associative law, that is A union B union C is same, is a simply shuffling of the bracket. Either you merge A and B and then C, and or either A merge with B and C. Similarly for the intersection it follows. So the proof we want to do it. So again, distributive law, here union distribute over intersection and vice versa. No need of doing the proof. You can prove it by using Venn diagram as well. De Morgan's law, A union B whole complement is A complement intersection B complement. A intersection B whole complement is A complement union B complement. Proof is very simple, because if X is a member of A union B complement, then X is not a member of A union B. Definitely X is not a member of A, X is not a member of B as well. X, it means X belongs to A complement and X belongs to B complement. Obviously, X is a member of both A dash and B dash. And similarly, you can do the reverse part and the equality holds true. Some important results on cardinal number union intersection difference. A, B, C are finite set and U be the finite universal set. Then this is here we use the principle of inclusion and exclusion. And again, if the sets are disjoint, then it will be same. And this can be also done by making the Venn diagram. A number of element A delta is the number of elements which belongs to exactly one of A or B. This is for 3 sets. Number of elements in exactly 2 of the sets A, B, C. It is a very good formula. Directly you can use it. A intersection B, B intersection C, C intersection, and thrice of that minus this, because in all these intersection, this triple intersection is counted thrice. That is why it is minus 3 times. number of elements in exactly one of the sets A, B, and C. Now see, when we are counting A, B, C, then this intersection counted, so we minus is twice and thrice the part of that. So you can use this formula directly. Now some exercise for you. Now there is a question number 1. Let the sets are given A, B, C. We have to find all sets X such that which has this condition. So this will be an exercise for you. I'm just sharing the solution part of it. You may note it down, and you have to discuss it with me. So for timing, I'm just sharing the solution, so you can hold the screen for a while and you can note down the solutions. Now again, we have let A equal to B, then we have to prove this. Now you can see, watch the solution. Simply you have to use your brain here. First you note down the question, that's it. You have to do it your own. I'm just, you see the question and do it by own. 3n means and 7n means is multiple of 3 and 7, and you have to find their intersection. Now A minus B intersection C is A minus B union A minus C. We are proving technique. Now see, we will use the left hand side is a subset of right hand and vice versa. Now see, you can use this technique. It's just arbitrary element technique that we have discussed in the class. So you proceed, these are simple reference for you, so you make use of this reference. Now see, A union B minus B, and what is that? X intersection Y complement, so it's something like this. Now use distributive law. Now this is again, this is is A minus B, and A intersection B is phi, so therefore it is equal to A. So it is indeed as a good question. Again, it is a question that we already discussed. X belongs to C, X is not a member of B, A is a subset of B, A is not a member of X, is not a member of A, and so hence proved. These are some questions that you can watch it and you can do it at your own. I'm just sharing the solution. Method 2 is the Venn diagram method that you can use your own brain here to solve the students. A and B be the two sets containing 3 and 6 elements. What can be the minimum and maximum number of elements in here? It's an interesting question. Let us discuss. You know this formula. A union B is minimum or maximum accordingly, and intersection. Obviously, this will be minimum when intersection is maximum or minimum respectively. When any intersection is minimum, it is 0. So this is only if A and B are 5. So this formula. So in this case, 9 elements are possible. In this case 2, when it is maximum, this is only possible when A is a subset. In this case, A union B will be B. So there will be 6 elements. Now this is indeed is a good question. So please students, go through. Out of 880 boys in a school, 224 play cricket, 240 play hockey, 336 play basket. Of the total, 64 play both basket and hockey, 80 play cricket and basket, 40 cricket and hockey, 24 play all the 3 games. Find the number of boys who did not play any game. It means from the union we have to find first we are finding the union. That union is already found. Now no, not playing any of the games. The total students may say you will minus the union part, and you now second method you may use this method is slightly lengthy, but the first part I will suggest the first method, but it's up to you if you want to use it. because it has a lot of calculation. But at last, thank you everyone for bearing me for this. I hope you like this.